Hello everyone. Today we're going to solve question number 21, merge two sorted list. You are given the head of the two sorted lists L1 and L2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes from the first two lists. Okay. Return the head of the merge linked list. Okay. So basically you can see already there are two lines of this codes. Okay. These are, if list 1 does not exist, then you can return list 2. If list 2 does not exist, you can return list 1. Okay, these are for these example 2 and example 3. You can see if the list 1 and list 2 both are empty, then you have to return the empty list. If list 1 is empty, you are going to return list 2. If list 2 is empty, then you are going to return list 1. Okay, so that covers this part. Next, we'll discuss three approaches in this video to solve this question. Okay, so let's see them. So basically, the goal of this question is that you will be given two sorted lists and you have to create a one combined merge sorted list. Okay, so you can see here we are using the same nodes. Okay, we are not using not creating new nodes to generate this merge list. So the question demands us not to make a separate list, rather use the same nodes to create a merge list. Okay, so let's see the first approach to solve this question. The first approach is going to be a brute force approach where my core idea is going to be I'll not follow the core rule, rather I'll just try to solve this question. Okay, so the brute force approach will say that store everything in array. Okay, rather than maintaining these pointers, it'll store everything in array and then sort it, and then we are going to recreate this list. Okay, so these are going to be simple tasks: create array, store them, sort the array, and then create the new list. Okay, so it will look like it will look something like this. You'll store all the elements from list 1 first, then from list 2, then we are going to sort them, and then we are going to create new list. Okay, so although we are like breaking rules of this question, but we have to see how the question, what are the issues in the question. Okay, so first what you can see is we'll need a vector. So vector and you can name it as vals. Okay, now I'll use a pointer. So list node star temp is equal to list 1. I'll store all the elements from list 1. So while temp is not equal to null, vals dot push back temps val. Okay, so I'm pushing values, and with that I have to move temp. So temp is equal to temps next. Okay, now I'll use the same pointer to insert list 2 elements. So list 2, now while same thing, so I'll just copy paste this, and okay, so temp, and it's going to temps val. Okay, so everything remains same. Now what we'll do is we'll have this array sorted. So sort vals dot begin comma vals dot end. Okay, so I've sorted this list or sorted this array. Now we'll just insert the values inside a new list. So for auto val given vals, we'll insert the values inside a new nodes. So list node star node is equal to new list node val. Okay, and we'll need something to point to head. Okay, so in this case I'll recommend to build intuition of using a dummy variable. So I'll just use list node dummy. Okay, because I might have to handle the head case separately, so rather than handling head case separately, I'll just create dummy and tail pointers. Okay, so list node star tail is equal to address of dummy. Okay, next what we'll do is we'll keep on adding to this tail. Okay, so tails next is equal to node and tail is equal to tails next. Okay, so this is the simple logic to solve this question. Now we are going to return dummy dot next. This way we don't have to worry about inserting in head case. Okay, so that's it. Let's run this. Okay, let's submit this. So that's it for this method. Let's discuss the better methods to solve this question. So first of all, I want to apologize that I didn't mention the time complexity and the space complexity in the last part, and I've also made some changes. Okay, so first we discuss the brute force approach, then we are going to discuss the recursive approach, and then we are going to discuss the dew pointer approach. Okay, the time complexity for the brute force approach was of n plus m log n plus m. This was due to sorting of that array, and the space complexity is going to be of n plus m because we are using array. Okay, and let's discuss the recursive approach to solve this question. The recursive approach is going to take a time complexity of n plus m and space complexity of n plus m, and the space complexity is due to the recursive stack that we are going to store. Okay, let's discuss this method. Okay, so as always, the recursive approach is like one of the low cognitive approach. So basically what you have to do is you have to solve one case and ask recursion to solve all the rest of the cases for you. Okay, you can see the time complexity and the space complexities for the recursive stack. Okay, the tasks that in this method that you have to follow are: first, you're going to solve one case for the current nodes on each list, then call recursion for that list next, and then you're going to return individual lists. Okay, so let me give you a feel on how this method is actually going to work, or it's how it's going to look. Okay, you can see here we had this list. So this is going to be something like a pseudo code for us. If the current list value is less than equal to the other list's value, in that case we are going to choose this element, else we are going to choose this element, or you can say this node. Okay, so you can see the calls are going to look like this. First we chose this first node, and then we are going to call for this next of this. So list one's next is going to be this call. Okay, so we are going to pass only the leftover list one. Okay, so 2 and 3 are only going past, and 1 2 3 for list 2. Okay, again, you can compare here. We'll do the same comparison for the next call, next recursive call. So in that case we'll have 2 and 1. In this case list 2 is less than equal to list 1. In that case we'll choose list 2. This call is going to look like this. Okay, so these are individual lists that we are picking one by one. Okay, the individual nodes that we are picking one by one. Okay, after this we'll have some call like this where we have chosen this node 1, and it's going to call for these list. Okay, again, so you can see in this case we are comparing 2 with 3. 2 is smaller, so list 1 is going to move ahead. So we are going to choose 2, and we are going to give call for the leftover list. Okay, and so on. Okay, so in this case it's going to move, and you might think, okay, after this one there will be a chance where list one is going to point to null. In that case what is going to happen? Okay, so as we wrote in the earlier method that this this part where if list one is not equal to, or the list one does not exist, in that case we directly return the other list, the list 2. Same way we are going to return uh, the same cases, hence this becomes our base cases for the recursion. Okay, so you can see these are our base cases for recursion. Okay, so let's write this method. So first we'll just need a check. So if uh, list one's value, okay, let me give some space to this method. Yeah, so if list one's value is less than equal to list two's value, in that case we'll have list one's, we'll choose list one, and we'll have list one's next is equal to merge two lists, list ones next, and list two. Okay. So this is going to be a recursion, and in the end we are going to return list one. Okay, so this return list one is basically we are constructing the list from backwards. Okay, so you can imagine the base case hits first, then we constructed these last list, and then we move toward this direction. Okay, we are moving towards this direction, although you are seeing that we are picking one by one elements. This is all inside recursion. In the end, when we hit a base case, we are going to return from it, and then we are filling a linked list. Okay, so yeah, return this list. Else we'll have this case list 2 is next is equal to merge two lists, list 2's next, comma, sorry, list 1 and list 2's next. So don't mess up the order. Okay, list 2 is next, and we are going to return list 2. Okay, so that should solve a problem, and you don't need any return case in this method. Okay, so let's run this. So yeah, so we have solved this. Let's submit this. These two cases handle the example 2 and example 3, and these also work as a base case. Okay, so that's it. Let's move on to the next method. So now we're going to see the optimal approach to solve this question. This method is going to be two-pointer approach, which is going to take a time complexity of n plus m and space complexity of O of 1. This method is going to follow this rule where the list should be made by splicing together the nodes of the first two lists. Okay, so let's see how this method works. Basically, the core idea behind this method is going to be we are going to use two pointer to keep track of current node, and we are going to append the smaller variable or the smaller node to a tail. Okay, so we are going to create two pointers to pointing to the heads. You're going to logically add nodes till one of the list is empty. Okay, and once we reach a point where one of the list is empty, in that case this third case is going to run where the other list which is not empty is going to be appended to the tail. Okay, so this is the list visualization part. Okay, don't get confused if both of the values are same. You can choose any of these values, the answer won't change. Okay, so let's visualize this. So to solve this question, we'll use this three-step formula. First, we'll connect to the node that is smaller one. Then we are going to move our temp. Then we are going to move our tail. And we are connecting this with tail. Okay, so the smaller node is going to get connected with tail. Then we are going to move temp. Then we are going to move tail. Okay, let's visualize this, how this method is going to work on this two linked list. Okay, so this is going to be our dummy, which is, and we have tail which is pointing to dummy. Now we'll have a temp1 and temp2 at the beginning of each of these linked lists. Now you can see first we'll compare one with one. You can choose any of these, so we can just connect a tail to this one. Okay, so I have connected tail to this one. I have moved temp and I have moved tail. Okay, so first I connected dummy with temp1, then I moved tail, then I moved temp, and then I moved tail. Okay, so this was first. Again we'll do same here where we compared 2 with 1. Okay, so in this case you can see temp1 is pointing at 2 and temp2 is pointing at 1. So since 2 is greater than 1, in that case our tail is now going to point to temp2. Okay, tail is going to point to temp2. Now we are going to move temp2 and we are going to move our tail. Okay, so tail is basically pointing to the last node that we have inserted inside a newly created node. Okay, so you can see tail, we connected tails next with temp2, we move temp2, and then we'll move tail. Okay, so connected, we move temp2 and we have moved tail. Again, we'll compare 2 with 3. So you can see temp2 is at 2, temp1 is at 2, temp2 is at 3. Now we are going to connect them. So we have to connect this tail with temp1 now. Okay, so you can see here we'll connect it with temp1. We are going to move temp1 and we are going to move tail. Okay, same way you can see here, we'll just rinse and repeat. That's basically the same thing. The important case comes here. Okay, in this case you can see we have this case where we have this null after this. Okay, we have after temp1 we have null for it. Okay, so in this case we are comparing 3 with 4. Okay, so at this point we had temp1 at 3 the last node and temp2 at 4 the last node, and tail is at this 3. Now we are comparing 4 with 3, hence we are going to update this way where tail is going to point to 3 now because 3 is a smaller element. Now since it's pointing to 3, the temp is going to be temp's next and temp is going to point to null. Okay, in this case our while loop is going to break, and for that we'll add this you can see if we return directly after this while loop, we'll have this element lost. Okay, hence uh, after completing this while loop we have to insert this temp to two tails next. Okay, so that's it for the visualization. Let's code this one. Okay, so basically what we'll need is we'll need list node star, or list node dummy 0. Okay, and it's a special case on how you're going to choose the dummy is going to point to which node or which head list head. Okay, so this is a very standard code where you're going to choose dummies next is equal to either list one's value if list one's value is greater than equal to list two's value. Okay, in that case you're going to use list 2 because this means list 2 is smaller, else you are going to use list 1. Okay, so this is a ternary operator that I'm using to tell which is this smaller one. Okay, so this is just for which correct head to point. Okay, secondly we'll have a tail, so list node star tail is equal to address of dummy. Now we'll need two pointers, so list node star temp1 is equal to list 1, or you can directly use original list because we are modifying it, so you can directly use them too. List node star temp2 is equal to list 2. Now we'll iterate using while loop, so while temp1 is not equal to null and temp2 is not equal to null. In this case what we'll do is we'll check for our logic. Okay, so if temp1's value is less than temp2's value. Okay, so if this is the case, in this case what we are doing is we'll we'll do that those three steps. So first thing is going to be connect, so tails next is going to be temp1. Next we'll move temp1, so temp1 is equal to temp1's next, and we'll do tail is equal to tails next. Okay, so move connect and then move temp, move tail. Okay, else case is going to be same but for temp2. So else case is going to be same but for temp2. Control V, and this is going to look like this. We'll have temp2, we'll have temp2 and temp2. Yeah, so now we have sorted on if both of lists are not empty. Now we'll handle the case where one of these lists are empty. So if list or you can say temp1 is not equal to null, in that case we are just going to connect tails next with temp1. Other case, if temp2 is not equal to null, in that case tails next is equal to temp2. Okay, so this is the last part. Mostly we forget that there could be a case that there are still elements left in the non-empty list. Okay, and in the end we are going to return dummy dot next. Okay, so that should do it. Let's run this. Okay, let's submit this. So we have solved this question using two-pointer approach. Thank you.